Good morning and welcome to today's soil compaction workshop. My name is Richard Fennessy. I'm a research scientist at the Department of Prime Industries and Regional Development, and I'm based in Bunbury. Thank you for your patience this morning. IT is definitely not my strength, so there might be a few delays in getting us connected today. So just to let you know, this is being recorded and streamed to half a dozen participants around the state and also across in South Australia. So welcome to everyone joining us online. May I start by acknowledging the Wadani people who are the traditional custodians of this land, and I'd also like to pay my respects to elders, both past, present and emerging. I'd like to start by introducing the topic and giving you a little bit of background into what sort of brought us here today. So back in July 2021, Wines of West Australia conducted a research development extension strategic review. And the outcome of that review was 6 strategic priorities to focus our resources. One of those priorities was to understand why vineyard yields are in decline across the state. And so I think we would all agree that there's probably a multitude of factors that are contributing to yield decline. And I think, again, most of us would agree that it's reasonable to consider that soil compaction might be a contributing factor, particularly in these vineyards in excess of 20 years of age. I was just saying to someone earlier this morning, if you can imagine an average of 20 tractor passes for each season, times that by 20, it adds up to a considerable amount of traffic within the vineyard. Surely there must be some sort of impact based on that traffic load. So today we want to explore the topic of soil compaction. And I want to make it clear that we're not saying it is the factor contributing to yield decline, but it's definitely worth something to think about. Today we've gathered a group of expert speakers joining us here in person in Margaret River, but also joining us online from Adelaide. So I'll introduce them as we progress through the morning. The objective of today's workshop is really to refresh our knowledge on soil compaction, explore how to identify soil compaction, understand its impact on root function, and discuss remedial strategies. The things that we work a lot on in vineyards, very visual, so we can see pests and diseases. We can see how the vine's growing above ground. We can't really see what's happening underground. So really important to maybe bring back our attention and talk about what's happening beneath the ground. So to give you an insight into what we'll be covering today, our first speaker will be talking about soil compaction, providing a bit of an overview, then leading into how grapevine roots, I guess the physiology of grapevine roots, their structure, function, etc. Then we'll talk about the management options that have been utilised in Franklin from testimony, and then a case study from Margaret River, which was recently completed, which I think most of you will find very interesting. And then again, another local testimony on dealing with compaction in local vineyards. After each of the presentations, there will be room for probably 1 or 2 questions, but we'll also be having a Q&A panel at the end. So if you do have any burning questions after a presentation, you don't get to ask that to the presenter, just keep note of that, and then you can put that towards the panel at the end of the workshop. So let me just quickly prepare for our first speaker. Okay, thank you for your patience. I introduce our first speaker for today, Dr. Tony Profit. In the early 1990s, Tony worked for the WA Department of Agriculture. We're all good people, work at some point in time. In that time, Tony was investigating the benefits of minimalising compaction by using the same wheel tracks for all operations in broadacre farming. In the late 1990s, the CRC for viticulture, headed by Dr. Alf Cass, established deep ripping and undervine mounding trials in Coonawarra and Pathway vineyards, which Tony got involved with in his role with Treasury Wine Estates. Tony joined AHA Viticulture in 2001, where he continues to work on a casual basis. Between 2009 and 2017, he also taught, probably in this very room, viticulture units for Curtin University's grape and wine degree courses, and he's currently helping Patrick Island with a revision of the textbook, The Grapevine, which was first published in 2011. Welcome, Tony.
Everybody, some of you I know, some of you I don't know, so welcome here today. Okay, so I'm just going to talk about a bit of an overview of what soil compaction is about, a little bit of the physics behind it as an introduction, so they're all aware of. So what is actually soil compaction? It's just the application of a load onto the soil. It increases the bulk density, or a term which I'm sure you all have heard about. There's porosity in the soils, therefore, as that bulk density increases, that airfield porosity decreases, and of course the continuity between the pore spaces, which is important for both air movement and also water movement, becomes decreased. So it's really a particle-particle contact is squashed. So on the left-hand side, I've got sand grains. You'll see the root system. On the right-hand side, it's a lot more squashed, being more compacted, and therefore there's less air between the sand grains, and water is reduced, and also plant root system has changed. So how does it occur? So the compactability of soils we'll talk about, but it's basic, but it occurs through either vehicles, trailers, some of the the fungicide sprayers now that we're pulling around, of 4,000 litres, so it's 4 tonnes, tillage implements, and animal hoos if we've got sheep in our systems, and a lot of people now do graze sheep. But the important parts of how the degree of compaction will be on the soil texture. Soil texture has a big component and a big importance to it. Moisture content, whether it's dry or moist. The percentage organic matter. More organic matter, the less compactable the soils. And of course, then the pressure load, the source of that. So what weight are we talking about? What shape and what contact are we having? So susceptible soils. So generally, the loams and the clays are more compactable than sandy soils. But having said all that, sands and sandy loams can also compact. So some of the work that we were doing back in the 90s that Richard referred to are actually on the sand plain soils in the northern part of the wheat belt, mainly sands, but a lot of those were very highly compactable. But it's all to do with the soil particle and the aggregate size distribution of the actual soils. So more broadly graded, so in other words, a more even proportion of all the sand of the sizes of particles, and I've got some curves in the next overhead. The more broadly graded, so they've an even distribution of all the particles from small to large, the more compactable will that soil be, because it packs easily. So if we actually look at that, So this is a top graph showing the well-graded soils. So they've got even distribution of soil particle sizes from the clays right up to gravel. Whereas a poorly graded soil, which only has a certain percentage of sizes in that curve, will be less compactable, and it's purely to do with packing theory. So if we go through some of those causes of soil compaction. So vehicles is an obvious one. So we're all running tractors and various other implements and trailers up and down our vineyards numerous times per season. So every vineyard is likely to have some wheel tracks within a metre, half a metre to a metre from the vine rows. So if we assume that there's minimal root activity past those wheel compaction, the potential soil volume, if you actually think about it, decreases to about a third if we're talking about an average row spacing of about 3 metres. So it's this topic that we sort of want to perhaps think about and potentially explore further. So if you've got an inadequate root system, and particularly it's the feeder roots, which I'm sure Megan will talk about later, maybe this is a factor exacerbating poor or declining vine performance. We're not very good as an industry, in my opinion, of digging holes, digging soil pits, and actually having a look at what's actually happening in the ground. We concentrate on the aerial part of the vine. We're more reluctant to start digging below. And of course, that's obvious why we do that, because it's not as easy. So if you actually look at the physics behind a wheel traveling across the soil. So down at the bottom, the base of the wheel, what we call zone A. So there's a concentration of downward and shearing stresses occurring at that point. In zone B, which you'll all recognise, we've got a bit of a hill. So you've got this furrow system, which is resulting of some soil being moved upwards. And then in zone C, immediately below the wheel, this is an area which is subject to a really intense sort of shearing action, particularly if there's actually wheel slippage going on. So if it's wet and the wheel starts spinning, then that shearing action is exacerbated even further. So we'll all recognise, and you will as well. So when we're driving on drier soils, or just slightly moist, the stresses are going to be generally resisted by the soil. But when we're driving on soft, moist and malleable soils, then that's when the greatest smearing and compression occurs. So just as an example, the effect of soil moisture on compaction pressure. So in this particular graph, there's three identical tyres, and we can see, so tyre size is the same, the load is the same, the pressure is the same. But it goes, this is cut off at the bottom, but at the bottom on that axis is, on the left-hand side, is hard, dry soil. In the middle one is soil with normal density and water content, and here we've got the wettest soil, so from dry to wet. Same load, but you can see the depth increases in terms of the zone of where the actual stresses are occurring, the wetter the soil. So wetter the soil, the deeper those pressures from tractor, fungicide sprayer, whatever is occurring. So if we take tillage, we're probably not doing as much tillage now as we used to. Generally, we've got a permanent sward in the mid-row, but there may be a time when we are doing some tillage. But when we do that, roughly 30 centimeters below the surface, we'll find that there is a tillage pan. So a tillage pan is really just a hard layer. So this is an example here of a compacted layer, roughly about 30 centimeters from the soil, from continuous travelling up and down with a tillage implement. I suspect we're seeing less of that these days, just because we're not tilling the soil as much as we used to, certainly in this region anyway. Animals is the other one that I mentioned as a means of soil compaction. So animal hooves exert a load on the soil, and again, the degree of deformation is really dependent on that usual the soil texture, the bulk density, the moisture content again, the organic matter, and in this particular case, the sward strength. So if you've got a good cover crop, permanent sward, then the impact of sheep in our vineyards is going to be a lot less reduced. But as an example of the compaction from animals, there's two. I'd like to just concentrate on these two. This is work that I did back in my department bag days. So these are slices through the soil. So samples of soil were taken, they were impregnated with araldite, with a fluorescing dye, and ungrazed on the left, grazing on the right. Black is pores, soil pores, white is solid soil. So you can see quite clearly that the porosity is a lot greater on where there's been no grazing compared where there has been grazing. And also the connectivity of macropores is a lot greater over here. We've got these big macropores connecting up to the surface. None of that over here. So 20% porosity towards the top, 5% porosity over here. And again, less than 2% where it's been grazed. Around about 5% porosity below. So animals do cause a problem. Remembering when animals graze, generally, so sheep, for instance, only got two legs, feet, hoofs on the ground at any one time when they're walking, and they also walk at a point. So the surface is very pointed. So the stress that's actually at that point for the whole animal is actually significantly high. So the problems associated with compaction. So I'll throw that out to you guys. What do you envisage as some of the problems associated with soil compaction? What experiences have you had, or what would you think would result as a point of surface compaction? Water doesn't infiltrate it. Perfect. Yeah. Good, Michael. Anyway, come on. There must be other people with experiences out there.
Microbial activity, feel less air down there.
Yeah.
Less water.
Yeah.
Everything.
All those things.
Visualize.
Okay. So these are the thoughts that I had anyway. So we've got direct changes and indirect changes. So without a doubt, you'll have reduced infiltration. So it's both rain and irrigation. We'll certainly have reduced porosity. So you've got soil aeration deficits. Remember, we've got a whole root system down there. It doesn't like being in a waterlogged situation. Waterlogging, possibly erosion, if we've got on a bit of a slope. Increased resistance to root penetration, and we'll talk about that a little bit later. Perhaps reduced root distribution and access to soil, water and nutrient reserves. So that's what we're talking about. Are those roots actually getting past that wheel track and into the mid-row? Possibly not. We might be seeing some poor growth and productivity, and certainly we'll be getting reduced access to the vineyards and timeliness of operation. So we know in this region, and certainly there are plenty of other regions who've had received a lot of rain, they just cannot access those vineyards. And this is quite common. Wheel tracks full of water. Can't traffic them, or else you end up in this sort of situation. So reduced timeliness of operations is an issue. So how do we quickly identify soil compaction? Well, there's a number of quantitative ways. Penetration resistance is one. Measuring, which we can do with an instrument such as this. That is a soil penetrometer, which we'll talk about. We can measure soil bulk density, which means you have to take cores in the soil. It can be done, but it's not easy and a bit fiddly, and therefore we won't take we won't take a lot of core samples to, and therefore we may not be covering all the soil variability issues. And airfield plot is something you can calculate from dry bulk density measures. So without a doubt, the soil penetrometer is the easiest method. It's quite rapid. We therefore can do lots of we can take lots of readings, which is obviously important if we want to be sure that we're covering the variability of our soils. But very sensitive to soil water content, as you can imagine. A bit easier to push something like that into the soil if it's wet, much harder if it's dry. So the readings will be very different. So therefore we have to do it at a similar moisture content each time we do the measures. And the ideal one is around about field capacity, close or at field capacity. They also have a problem in soils like Margaret River, which we encountered in our study, because there is gravel in our soils. So sandy soils, perhaps Jindong Way may not be such a problem, but in a lot of the other vineyards we have stones, we have gravels, and therefore when that hits that, then there are problems in terms of getting that data. So it's basically a rod pushed into the soil at an even degree of pressure, and the got a cone at the bottom pushed in. This is the rod, and on here we have a data logger which records the degree of pressure that we're exerting. Push that into the soil. And finally, yes, we can do all those things, and yes, we can determine whether we think we've got a soil compaction issue. But the key thing also afterwards is to observe what's actually happening in the soil by digging some soil pits. So yes, we can determine whether we have some issues or not, but let's dig some soil pits in the soils and actually have a look and confirm whether those values that we're getting from a soil penetrometer actually translate into something in the soil that we can actually observe. So if you are digging soil pits, set up like this is the perfect way of doing it. So we need to start up close to the vine row, out to the centre. Ideally, if we can get down to a metre, that's good. Because metre may be where we find still some roots. We should expose the roots on both sides to see whether there's a difference on this side compared with here out in towards the mid-row. Often people will, the researchers have painted these white so they clearly stand out. And as Megan will probably talk about a bit later, part of the root system has what we call feeder roots. And if you we should expose those, and ideally, in my opinion, cut those to see whether they are alive or dead, and it's very clear whether a feeder root is what is dead on or not. So we need to determine those. So have a look at some of your what's happening in the soil if you feel that there's some compaction issues, and it's a good thing to do anyway, just to see what's happening. I'll leave it there.
Great. Thank you, Tony. Maybe time for one or two questions for Tony.
I'll just add also, and I'll talk about this in the next topic, but a lot of this work is not new in terms of compaction in vineyards. There was, as Richard said, the CRC for viticulture, the Cooperative Research Centre for Viticulture that existed in the 90s, was headed by a guy called Alf Cass, and he did a lot of work on this sort of area. So looking at soil compaction in vineyards, as I say, is not necessarily new. Alf did a lot of work. He wrote a lot of very readable articles, of which I brought about 6 or 7 here, all by Alf, and a lot of that is also about how to observe soil compaction, but also about ripping, wing ripping, deep tillage of soil for production, retro ripping, rigorous approach to remedial tillage. All these were written, and if you have an interest in these, I'll leave them on the table there. You can just have a browse through, but they're all available in various forms. And the other thing I'll just bring your attention to, and again, we'll talk about it in my next presentation, is that there was a publication done back in the 90s, 1996, called this, and it's called The Root Systems and Soils in Australian Vineyards and Orchards and Assessment. And I'll talk about this report a bit later, but again, I've got a copy here so people can have a look at. Yeah, sure.
Regarding the grazing, is there, I know it depends on the soil type and soil and everything, but would there be a general average or recovery time after grazing?
Oh, well, certainly I can only speak really in the broadacre stuff that I was doing, but certainly, so in broadacre, they were concerned about when they were growing a crop, they were concerned about poor soil structure, hence we went into direct drilling, etc. Then if they were in a wheat sheep rotation, that first year of bringing sheep into the system in terms of pastures would undo everything they'd done in the cropping phase in terms of direct drilling and improved soil aggregation. But again, that can, as soon as you, if that was tilled, then that would go back to normal. In terms of a vineyard, I don't believe that sheep are such an issue at all, because where we have good cover crops, I think we probably have, I think we don't realise what sheep are doing in terms of the removal of nutrients from the vineyard system. We bring nice skinny sheep into the system, they graze, go out a much greater weight, and all courtesy of the vineyard, thank you very much. So I think there's some issues associated with having sheep in the system from that point of view. I don't think they're doing a lot of structural damage where we've got good cover. But I would think that within a year, that if there was some impact, then you would recover pretty quickly in where the soils are managed well.
So do you think maybe how wet soils are getting maybe does make that a bit more difficult?
Yeah, I think if we're going to get wetter winters and we've got sheep on them, then I think there's a potential issue. I'm also get a bit concerned about how many sheep I see in vineyards. So a lot of it is to do with stocking density. So if we bring a big mob of sheep in, it doesn't take long for a lot of that cover crop to get eaten away, and it starts becoming, the sward becoming less and less. So I think the then at that point in time we should be removing the sheep, but we tend to keep them for the whole, up till bud burst or something, so at a very high rate. So I think we need to be very mindful of the stocking rates that we've got in the vineyards, and particularly if we are getting wetter, if it's a particularly wet winter, because they will do, without a doubt, they will do damage to the soils if they're susceptible soils.
It's some grazing probably has a place in it, what it does in sheep farming in the blood, which is hard to do, but it's worth thinking about which one finds a chance to recover. So.
Thanks, Tony. So we will move on. For those of you that didn't pick one up, there is an article that Tony and Lee have authored for everyone's interest. If you haven't got that, there's copies at the front of the table there. Very pleased to introduce our next speaker, who's joining us online from Adelaide, Dr. Megan Sheldon. Megan, if you'd like to turn on your camera and microphone. Megan is a plant molecular physiologist and senior lecturer at the Waite Campus, University of Adelaide. She gained a PhD from the University of Adelaide, where she compared different grapevine cultivars for drought tolerance. Her main research focus is understanding root adaptation to abiotic stresses, particularly saline soils, in both cereal crops and grapevines. She also teaches into the Bachelor of Viticulture degree at Waite. Thank you for joining us, Megan. If you would like to share your screen and your PowerPoint, we'll make sure all that's working, and then I'll throw it over to you.
Can you hear me? Yeah.
We can hear you loud and clear.
And you can see the screen?
We can see your screen.
Excellent.
Over to you.
Okay. So firstly, thanks, Richard, for inviting me to speak today. And so I'm going to give you a bit of an overview about structure and function of grapevine roots. So I'd also like to acknowledge and pay my respects to the Kaurna people, which is the traditional custodians of the land that I'm on today. And I acknowledge the deep feelings of attachment and relationship of the Kaurna people to country, and I respect and value their past, present and ongoing connection to the land and their cultural beliefs. So I'm going to just give a bit of an overview about the grapevine root systems, so types of roots, the purpose of roots and how roots grow. It's a bit of a basic 101 lecture, I guess, on roots. I'll also cover the functions of roots and mechanisms that they use for water and nutrient uptake, and I'll touch briefly on soil compaction and root growth at the end. Okay, so the key functions of any root system of a plant, but of grapevines as well, is to provide a physical anchor in the soil. They also absorb water and mineral nutrients from the soil solution. So all water and minerals are taken up into the roots, and they're moved up through the xylem through the process of transpiration and into the leaves, where they're used for photosynthesis. Grapevine roots also store carbohydrates and nutrients, so in their dormant in winter, and this is in reserve for future use. So when they burst in spring, they reutilize these carbohydrates and nutrients. Roots also produce hormones that control plant function, so these are involved in signaling to the shoot. So you can see there's quite a complex relationship between the scion and the roots, and there's also the interaction with the atmosphere, and then you have the interaction with soil, so soil composition, structure, temperature, nutrition and water, and also pathogens mycorrhizae and invertebrates. So it's quite a complex interaction that's happening. So I'm just going back to real basics here about how roots actually grow, because many people don't actually really think about this much. So roots grow from the very tip of the root, and this is actually quite a small region. In grapevine, it's up to about 3 centimetres, and this just shows the tip of a root on the right hand side. I'm not sure if you can see my cursor. So and at the very bottom you've got the root cap, and this is cells that actually protect the tip of the root as it's penetrating the soil. So these cells actually get sloughed off and get replenished as roots penetrate through the soil. Behind this you have the zone of the meristematic zone, which is where cell division occurs. So this is where all your growth is happening, and then the cells elongate. So once they finish elongating and the cells are at their maximal length, they enter what's known as the maturation zone or differentiation zone, and this is where cells differentiate into different cell types. So you start to get your vascular tissues forming, the phloem, xylem, and other layers. The epidermis, you start to get development of root hairs, and then above this is where you get lateral root formation. And so here I've just shown this 1-year-old root, grapevine root, and you can't see any root hairs on this because it's been grown in solution, and they don't develop root hairs generally in hydroponics. But you can see here you get this lateral root development, and then you're even getting secondary roots, secondary laterals coming off of the primary laterals. Roots, you also get the secondary growth and thickening in grapevine. So you're starting to get the woodiness that you see in the old roots, and you get development of the secondary phloem and secondary xylem and the cambium and the wood rays. So that even happened. That's the 1-year-old root section shown there. So as I'm sure you all know, that vines are vegetatively propagated. So the roots actually originate from the cambium layer of a woody cutting, and you get these white roots. The younger roots are white that develop, and as they get older you get the browning occurring. So in a root system, this shows a concord vine, that picture I found of the root system, and you get these main framework roots. These are between 6 to 100 millimeters in diameter, and they grow down to a depth usually further than 30 centimeters, and they're thought to remain constant for more than 3 years. And then you get the smaller permanent roots. These are actually the lateral roots, so these grow off of the main roots, and they're usually 2 to 6 millimeters in diameter, and they can grow horizontally or vertically through the soil. And so to show you a mature root system, and just sort of reiterate what I said, this is you can see the main roots here coming off the trunk. They develop down into the soil profile, and then you get the lateral roots, and you can get second and third order lateral roots as well coming off of here. And then as Tony talked about, the feeder roots or the vine roots that develop up more at the top in the surface layers, and these are really important. They grow each season, they're seasonal, and they're continuously replaced, and they're really essential for the water and nutrient uptake that happens, whereas the main roots and the provide anchorage mainly. So just talking about the feeder roots, as I said, our growth is often seasonal, and I actually struggled to find too much literature on this, but I found this graph that illustrates that the fine root number increases at different times through the season. I also found another paper, which I haven't included, but they showed similar results, but it actually changed depending on the climatic conditions for that year. So in dry years, it was quite different to wetter years of when the growth occurred. But you can see this does vary quite a lot, and they grow in the top 50 centimetres of soil, and so you get high turnover of these roots. And again, I found quite a variation in literature on how often they turn over. So I found anything from a month to over 150 days. So it might be quite dependent on the soil type or climate and rainfall. Fine roots also form associations with mycorrhizae fungi. These form a symbiotic relationship with the plant, and the fungus actually enhances the uptake of nutrients from the soil, especially phosphorus. So these are really important, and they're also, as I said before, essential for water and nutrient uptake. Yeah, so just to go back, so the key functions of the root system, the permanent roots really provide the physical anchor for the vine, and the fine roots do the bulk of the water and uptake of water and nutrients. And then you have the permanent woody roots that store the carbohydrate and nutrients in reserve for future use. And I haven't really talked about hormone control, which I won't today, but these are generally produced in changing conditions, so such as salinity stress or drought stress. ABA will be synthesized, and it signals the shoots to close the stomates. And so when we look at water and nutrient uptake, hopefully I haven't gone too complicated here, but I just wanted to sort of reiterate how water and nutrient are taken up from the roots. So the nutrients and ions are in the soil solution, and they're taken up into the roots through the root hairs, or they can cross the membrane. There are two different pathways to get across the root. So they need to go transversely across the root into the xylem to get up to the shoot. And they can go either around the cells, which is called the apoplastic pathway, or the symplastic pathway, which requires movement across cell membranes in and out of the cells. And to do that, you have membrane transporters that are involved for both ions and for water. And then this is also the pathway of toxic ions get into the plant. So when in like high salt conditions, or if you have high levels of boron, they also move through the plant the same way and go up towards the shoot. So root growth in the soil can be affected by many factors, and when we're talking about root growth, we can think of all different parameters. There's the overall root length, there's depth, there's the type of root and branching. So often you can get less lateral roots under certain types of stresses, and then you can get overall root density, which is kind of a compilation of how much root material you have in a certain amount of soil. And so this is all dependent on the soil type, and we know grapevines are often grown in Mediterranean and semi-arid climates with soils that have low fertility. Climate and stress will impact root growth, water stress, water logging, ion imbalance, and also toxicity to ions. Management practices, as Tony's already kind of touched on, different management practices will affect the soil and therefore will affect root growth. And you also have varietal differences, and also different rootstocks will have different root growth in different soil conditions. So I've just, I must say I'm not an expert on soil compaction, so I've done a bit of looking for some nice pictures, but as Tony's covered what soil compaction is, it makes it more difficult for roots to penetrate the soil, because roots do go through the soil pores, and so the bigger they are, the easier it is for roots to get down into the soil. One of the most important factors that is affected by soil compaction is root elongation and proliferation. So as I said, roots grow from the tip. If they can't get through, they just stop growing. And this will obviously impact on their ability to take up water and nutrients for growth and yield. You can see in these nice figures the impact of soil compaction, natural compaction on the left, and a traffic pan on the right that I found. And then this nice illustration of what happens when you have a much nicer soil that's not impacted by soil compaction. You can see all the root tips coming out. So you can see quite visually that the roots are growing much better in that soil. You also have what's known as a feed-forward response, and I touched on this before. When a plant is when the roots are under stress of any sort, they will send a hormone signal from the roots to the shoots. So if this soil is dry or it's compacted, the roots will synthesize hormones, and that will signal to the shoots to close their stomates, and you get a reduction in photosynthesis and growth. And that's shown here in this graph, where you get this increase in the pentometer resistance and this really obvious decrease in leaf area. Now I have to say this is done in wheat plants. I couldn't find any specific examples in grapevine. The other thing that I couldn't find much literature about in grapevines is root hairs, but root hairs are well known to affect root penetration. So they actually enhance root penetration. So they're actually really important in compacted soils, and different varieties and rootstocks will probably have different amounts of root hairs. But again, root hairs can also be affected by stresses as well. So under certain stresses, you'll get less root hairs. And Richard asked me to touch on the effect of ripping on root growth. And this again is actually an illustration of root depth. This is in wheat roots, but I just wanted to show this because I thought it was a really nice figure showing what happens in a rip soil. You get root growth much faster through the compacted, because they've broken up the compacted layer of soil, and growth is actually slower in the not ripped soil. So in a vineyard, ripping is usually done before a vineyard is planted, and it's done to improve root growth and access to deeper soil layers, because it breaks up the soil. But it's not always advantageous. It doesn't always improve root distribution, and it also can cause mixing of lower soil horizons, so it can introduce toxic factors to the roots. So things like salt and boron can actually be brought up higher into the surface soil. So I guess these are all considerations in managing a vineyard. So ripping in established vineyards after harvest will reduce the root density, and if it is done correctly, it should stimulate root growth by loosening the soil and increase productivity in the following seasons. And I just wanted to finish by just illustrating, as was mentioned in the first talk, it's really hard to visualize roots in the soil, and this is a big problem and why we don't know a lot about what's going on in all crops with root traits. And I just wanted to show, I thought this was really nice work that they're using 3D phenotyping now, using X-ray computed tomography, and there's an example in the literature now of grapevine roots. So this was a study done by a German group in collaboration with the University of Nottingham, where they have this really nice setup to measure root traits, and it is done in pots, but I just wanted to sort of illustrate this as something going forward that hopefully will become really useful to understand root traits better. So they had 3 different genotypes and 2 different types of soil, and it was more a proof of concept study because it's I guess this is really new technique, and but they could see the adventitious roots and lateral roots using this, and they actually did see a difference in the different soil types. So the grey bar is a clay loam, and then the sandy loam is in the orange bar, and in one of the genotypes in particular, they saw a difference in adventitious root length. And so it just was interesting to see that you do get these genotype differences and soil differences. And going forward, this sort of thing will be able to be used for studies like with soil compaction or different densities and also different stresses. So I'll finish there, and thanks for your attention. I'm happy to take any questions.
Thanks, Megan. Just through the interest of time, maybe just one quick question, and then the rest we can save for the Q&A. And also, any questions in the room for Megan?
I might ask one quick question.
Yeah, I might have to relay it because the microphone.
Yeah, just talking about root hairs and water getting in and the top 50 centimetres, and there's this concept you hear often about encouraging roots to go deep to access moisture, which I guess are the more permanent stabilising roots. So what role do you think there is for them to be accessing deep moisture 2 metres down or 3 metres down?
Did you pick that up, Megan?
Yeah, I did. So grapevines get really heavily superized. So my understanding is most of the water and nutrient uptake actually occurs by the fine and feeder roots, because I'm not sure if you're familiar with superization, but they get lignin and that deposited in the roots, and that makes it very hard for water and nutrients to get through. So I actually did try to find some literature on that as well, and because in other crop plants, yeah, the deeper the roots, the better access. But because of the superization, my understanding is those roots are they're primarily for anchorage. So, but I'm happy to be disputed on that if people are more familiar with some of that literature. But
Thanks, Megan. Yeah, we'll just bank the rest of those questions, and we'll rejoin Megan at the Q&A session at the end. Now we've got a new speaker who is here with us in Margaret River. And excuse me while I just attempt to get Lee's presentation up. Lee, please come up here and join me while I introduce you. So those that aren't that haven't come across Lee before, Lee's a very highly regarded viticulturist that comes from us from the Adelaide Uni back in '95, where he did his Masters in viticulture, but previously completed a Bachelor of Science majoring in biochemistry from Flinders University, and has worked in many wine regions within Australia and consulted throughout Australia and New Zealand. Lee's had some great accolades in recent years, including the Viticultural of the Year through Gourmet Traveller Wine in 21, from his activities in the Great Southern, and also Young Guns of Wine inaugural National Vineyard of the Year from his work at the Swinney Vineyards, where he was the Director of Viticulture for 8 years. He's currently the General Manager of Margaret River Vineyard Services, which is a management and contract services company, and also operates his own consulting firm, Muir Viticulture, that he started in 2006. Lee also is heavily involved in R&D activities here in West Australia through his involvement as the chair of the Wines of WA's technical committee, and admits to being a bit of a cultivation fan. So I'll throw it over to you, Lee, and welcome.
Thank you, Richard. Thanks for the introduction, and thanks to Tony and Megan for setting the scene really well. I thought that was a great introduction to the topic. I am a pretty enthusiastic cultivator, but hopefully I'll give you some basics for why I think it has a place. So some of the topics have sort of been covered pretty well by the previous speakers, so I might skip through some of the slides that I have here, but we'll see how we go. So I guess the topic, I guess we're almost accepting that there is a degree of compaction out there for what I'm presenting today. So there's a really good presentation that Tony's doing after me that will shine some, some actual data on the topic, whereas I guess where I came to this topic was I almost accepted that I had a problem and we were set about what to do about it. So I guess, minimising compaction is one of the goals. I mean, if you accept that we've already got some, you want to try and work out, how you might minimise it. I think there's a range of things here that I won't probably go through line by line. I think most of these are pretty well known in terms of how you would reduce compaction operationally. There's challenges to all of them, as we live in the real world here. I think probably the one that I like the most is organic matter. I think, if we had a magic wand that we could do something with our soils, we'd just put more organic matter in them. So I'll move on from that one. Margaret,
can I just, having a bit of a technical issue, our people online can't see your slides.
So I put that topic at the top there about subsoil drainage. I think that definitely has a place because we have these fairly wet root zones that that are often compounding the issue, and then we have to drive on them. We know we have to. So if we can get some of that water out of the system and we can get some organic matter into the system, I think that would be a pretty good thing. Right. But I think, I guess what I'm about to talk about now is we've accepted that we have a problem out there. So what are we going to do about it? We're going to have to be quite interventionist. This is not a tread softly. So I've called the term root zone resuscitation, which is maybe a bit provocative, but I often think that with perennial deep-rooted crops like vines, we want those root systems to be as expansive and a term that Bruce Pearce taught me a long time ago, which I quite like, is expansive and voluminous. We want these root systems to be as big as they can be and as active and as functional as they can be. So this is where we were starting. Okay, so you probably had a chance to skim through that in the intermission. I think that subsoil, there's a lot going on in the subsoil. There's a lot of nutrients there. There's a lot of things that we would like those roots to have access to. And we need those roots, as Megan sort of pointed out, we need those roots to be functional and able to absorb those nutrients as well. So, I've been sort of thinking about how to get those roots growing into those subsoils, and I think deep ripping is a way of getting to that. So, clearly there's some aspects of soil type that you really need to understand when you start thinking about deep ripping. If you do it too wet, it's just like putting a knife through butter. You'll smear it and you'll sear up the sides of it, and the roots really won't be able to go into that new soil that you've potentially enabled them to access. If it's too dry, you'll pretty much powder it, and that will recompact very, very quickly as well. So moisture content's really, really, really important, and I'm under no illusions about how hard it is to try and rip at the right time. It's complicated. And in Margaret River, and most of the work I'm going to talk about is in Franklin River, where the situation is very, very different in terms of the soils that we're working with and the rainfall patterns. But as you can see here, we've said there's two types to rip, which you probably know, straight after harvest. I think in Margaret River, that's the time to focus on. In Franklin, I could pretty much rip the soils from May through to September if the conditions suited what I was doing. So it's definitely harder here. But don't let that put you off. Still got to find a way through it, as I hope I'll help you to see. The bottom point is mounding. That's another way of giving a greater soil volume to the roots, and that is a pretty good hack. That definitely works as a short-term strategy. Gives some fresh soil to the vine, definitely works. And that's pretty well proven by some of the work that was done in the late 90s by Alf as well. So guidelines again, field capacity is about the right time. We'll talk a bit about tines, the type of implement that we're going to use to rip. Conventionally, people have used a wingless tine, which we've used that in one of our trials, and we've also got a wing tine. The wing tine has a different impact on the soils. If you've got sort of fairly clay-based soils, it'll work pretty well in terms of lateral shatter, and I'll try and illustrate that a little bit more in the environment. One of the big steps forward, I think, in ripping, which was, Alf Cass's work in the late 90s with CSIRO, is the vibrating wing that it allows even a different, gets a different result in the soils. I think the main compacted zone, and we'll talk about this in the next presentation as well, is pretty much under the wheel tracks. That's where the problems are, not surprisingly. So in the work that we've done, we pretty much always rip pretty much on the wheel marks, which for almost all tractors, they're somewhere around 1.8 to 1.7 to 1.9, that sort of range. Rake angle is important. A lot of this work's been done. The physics is pretty well established. There's some power thing, but I won't go into that too much. So my rationale for ripping in Franklin. So I started running the Swinny Vineyard in 2013. It was a large 15-year-old vineyard. It was in decline. We converted a lot of they were unilateral spur prune cordons. I'd known the vineyard, I've been involved with the vineyard for a long time before I took it on. Yield was declining. So we were well through this process of converting the vineyard to canes, and massively confronted me with fixed fruitfulness and yield potential. But then basically, so we've got a crop on these vines now after converting them all to canes, and they just struggled. They just super struggled. Like, we've gone from really low yields, high variability in the years prior to me taking it on. The vineyard's pretty irrigation dependent. The term I'm using at the bottom, late season stamina, the vines just really struggled in those last two months of the season. And that to me screamed, there's a problem with the root zone. They're just not large and viable enough. I've skipped over some of the points that helped me to maybe think compaction was the issue, but infiltration rates, which we talked about before, and just the mid-row, it was all just wild oats and Guildford bulb, and I was like, that's just not a cycling system. So I don't know, I probably should try and describe late season stamina a bit more. It probably means a lot to me. It's not a standard unit, but when those vines are really struggling, they just look unthrifty and dull, and they're just really struggling, and you've got to help them through those last couple of months with a lot of water, which just does not lead to good outcomes in terms of the wine grapes we're trying to grow. So in my mind, compaction is one thing that we can do something about. So let's have a go at getting to know these soils a bit better. So I guess I've often thought of myself a bit as a below ground viticulturist. I bought this machine back in, I don't know, 2008 or something. I've used that all over the Great Southern. You can very quickly put a core into the soil. Not surprisingly, they're all pretty compacted when they come out of that thing, but it helps you to know your soils really well. I mean, I've used that across a lot of vineyards, and I encourage people to, like Tony said, spend as much time getting to know your soils, and then you will know what you might want to do to help them. So in Franklin, we've got pretty strongly duplex soil. So the one on the left is a pretty typical, gravel, what everybody would think is pretty common in Franklin, and it's present. It's not universal. There's also quite a lot of clay-based subsoils like the one on the right. The one on the left, you can see the depths there. The ripper that I'm going to describe to you soon sort of can get to about 600 to 700. So we're getting into that clay layer and we're fracturing it. So that duplex soils respond really, really well to ripping. And they're pretty much describe the main Franklin subsoils and that you're dealing with. This one is pretty compacted. This actually isn't in a vineyard. Just want to point out that's where you might be looking for some grape forests, but they're not there because it's not actually a vineyard. But that illustrates the type of soils that
that we were dealing with there. I quite like this one. This is probably the first ripping I did when I was at Forest Hill in the developing vineyards in about 2007 or 8. But this was a Western Range ripper. It was what a lot of the farmers in the Mount Barker region used after cleaning timber off their land, and that's a 13-tine ripper. Maybe 600 horsepower, old versatile from our neighbour. If we prep vineyards for Forest Hill, I went over the road, borrowed that, ripped every which way, So I quite like that machine. So I put that in. Not relevant to the presentation, but so this is where we're going to talk about tines. Just two options that are out there commercially. The one on the left is a yeoman's. Very well regarded tool, widely used, very effective, range of configurations in terms of time, number and position. So a very good implement. The one on the left, this is a machine I bought in 2013 for Swinney. So this is a vibra soiler, quite a evocatively named ripper. This was done, so Ag Soil Works is the company that developed this machine. It's based in Adelaide Hills. Did a lot of research on trying to get the that vibrating wing that sits behind the tine to laterally shatter the soils. The reason I was particularly persuaded by this tool in the early, or when I bought it in 13, is that I had a process of I guess we were pulling vines out and wanted to leave the trellis in place. But what I really like about this tool is it can laterally shatter soils left and right of the tine by 300 to 400 mils. So when we redeveloped vineyards, we pulled the vines out, we left the trellis in place, we ran down the rows with the ripper as close as we could to the row. And if we trust the science, and I'm pretty sure it did, we are laterally ripping left and right of the tine. So we're pretty much ripping where the new vine's going to go. So I've seen a lot of vineyards, and you all would have seen them as well. Yeah, when they're redeveloped without some sort of fairly aggressive ripping, they struggle to get established. So probably set up a little bit, but so on the left, we've just got a standard tine. Nothing wrong with it. I'm not saying it's, but the characteristics of it are quite different. You won't get a lot of lateral shatter. Maybe you don't want that, but in the case that I initially bought the machine, I wanted it to redevelop young vineyards, but then I started seeing it as pretty relevant to established vineyards as well. And there's some really thorough research that's gone into this. There's some really good papers that Alf's done about that vibrating wing. So this is a picture out of the Ag Soil Works sort of data. Ag Soil Works established quite a significant headquarters in California. They seem to be much more willing to embrace mid-row cultivation there than Australia. So hence it's got feet and inches on it. But basically that's I guess more of a three-dimensional image of what I showed before, where you're getting that lateral shatter from the wing tine. And it's real, as we'll see. Look, it makes a mess. There's no doubt about it. I've ripped a lot of different vineyards over nearly 10 years with that machine, and it's pretty aggressive. Takes, in this case, we're pulling it with 130 horsepower tractor. Randall Tomic encouraged me to drive at 4 to 4.5 k's an hour with the ripper, because he said that's what you need to laterally shatter the soil. And I was like, okay, it's pretty scary. That thing will pull you around. If you hit a rock or a root, you're going to get pulled around. So it's hard to drive at 4.5, but you need a big tractor with a good platform to do it. So in this case, that's come up pretty well. I mean, that would theoretically be trafficable if you wanted to. That's not often the case because you get quite different results. So some operational aspects. I mean, there's supposed to be a video, but it hasn't actually come through. I guess you can see that tine. That's done a bit of work by now. The wing's looking a little bit narrower than it was. but that's vibrating up and down on a 2 to 3 times a second, not a second, 1 or 2 times a second. So it's doing this sort of speed. So when you're driving along, that's just operating on the hydraulics, and it's just doing its thing as you're driving down. There are plenty of operational aspects I probably won't spend too much time on, but what would have been happening here is the roots would have been building up around the front of the tine. So you've got to back up and clear them from time to time. And that created a whole conversation around whether, ripping roots was going to help or hinder. So I think we'll go into some observations about what happened subsequent to ripping, and I'm pretty evangelical about this topic, but we turned the vineyard around pretty dramatically over sort of a 3-year period. There was a fair few other things going on as well, but year 1 didn't really see a result, probably not surprisingly. What to do after ripping? Well, that's a conversation for everybody to have a think about. But what we did is we displowed, we power harrowed, and we cover cropped. And you think, well, that's 3 or 4 passes. Wouldn't that just recompact? Probably, but you've got to traffic the property, later. So you just pretty much got to get in to smooth it down. The things we noticed in that first year dramatically improved rainfall infiltration. Like, we just didn't have runoff at all. So and there's a lot of other observations, but that sort of really highlighted it. So in year 2, we ripped the alternate row. Same sort of thing. We did that ploughing, disc ploughing to smooth it all down. And then the next 3 to 6 years, we had significantly stronger vine performance. Now we had done other things as well. It's not just the ripping, but I think we'd reset the vine growth, and I sort of call ripping like we did there. I almost call it the control-delete of 20-year-old vineyards. Like it just resuscitates them and it gets them going again, while you hopefully buy some time to think about the other things you can do to strengthen the vines. So we changed the irrigation strategy a fair bit. We started going for deeper and longer, more widely spaced irrigation, and I think by severing the roots, we allowed new roots to grow into that environment that we were putting water into with a different irrigation strategy. This is probably a bit contentious and it's a bit hard to get your head around, but it's pretty real. I had some guys with me that had been working on that vineyard for a long time, and had always noticed, where the yield was on the belt of the harvester and where it wasn't. And they started saying, once we were harvesting 2 or 3 years down the track, they're like, there's just fruit all the way down the road. Like there's just not these ups and downs anymore. And I thought about that for like 10 years and still don't really know why. But I think if you've got different soil types, somehow the ripping seems to allow the vines in that particular location to cope with whatever limitation they might be, under. So I was there for 8 years. We started a program in the last couple of years of going back to that row that we'd first started on back in 2014 and doing it again. I think, in hindsight, I would have loved to do a bit more penetrometer work and a bit more soil pits, but whether it's 5 or 6 or 7 or 8, or it's probably not never again. But I guess as I've thought about this a lot since, the real improvements in our knowledge will come from how do we work out what to do subsequent to the ripping, so we don't have to do it again for hopefully quite a long time. This is some pictures that I'm grateful for Tony Prophet for sharing with me. This is some work that he did in Coonawarra a little while ago, and this is really fun stuff to do. But on the left we've got a non-ripped row, on the right 12 months post-ripping. A lot of work goes into excavating those roots and painting, and that's a very laborious task, but it's a pretty good thing to do. And not surprisingly, not surprisingly to me, I suppose, but we're seeing a lot of very strong root growth. So, are you devigorating the vine by root pruning it? Back when this work was done, the goal was to devigorate vines by root pruning, and I did it for some sites as well, and it had completely the opposite effect, which is useful for the point I'm making today. So yeah, you might set them back a little bit, but what you gain is certainly worth it in my experience. So this is where it gets a bit sort of off piste a bit. I'm not sure where that video is going to play. I think biological activity and organic matter, as I mentioned at the start, are going to play a really significant role. In the left, this is the compost band of spreader of mine. Unfortunately, I didn't have a video to show you what I actually did with this machine, but we can speed up that belt quite a lot. So we ripped the row alongside and we threw compost into the rip line from that row, for example. So if you can imagine, there's 2 rip lines in the row adjacent to where the spreader is. We cranked up that bander to much faster, and we were able to throw material across through the row, if you like, into the rip line. And we probably only got 60 or 70% of it, but as you'll see in a minute, I made a lot of compost, so I had a fair bit of it. So that's a great thing to do if you can crack that nut. This machine is a local contractor, Jeremy from BioAg. I think that machine has a place as well. I mean, there's a whole range of things you could put through that machine depending on your persuasion, but I like that machine. Discussions around timing. I suppose this is where the rubber hits the road. I mean, as I said in Franklin, I think on reflection, it was a pretty easy topic to do. I mean, we were close to 300 hectares by the time I resigned, and we had opportunities to rip through most of the winter. We had a lot of our own gear, so we weren't sort of adjusting our practices around contractors and things like that. So look, it was easier than doing it here. Like, I think what I've learned about Margaret River, by the end of May, you're probably done. And that the weather pattern will be different each year, but I think it's pretty early. We've done a bit of work in Margaret River with that machine over the last 4 or 5 years, which has been interesting, and we'll talk about that a bit when Tony speaks. I guess they're just operational matters, but timing around climbers and pollenks, well, that's for barrel pruners, that makes it complicated. And what we do is we rip the row if it's going to be barrel pruned, and we just put the pollenk in every second row. The climber, it's a bit more complicated. But I guess I do want to make that point pretty emphatically, probably. But compaction's real. It is limiting performance, and we all should just try and figure out what we're going to do about it. Organic matter matters, I think. So this is some tillage radish on the left with my son, thinking that he's got something for the salad, but they're not very good to eat, to be honest. But that stuff definitely has a place. I mean, the results you can get from tillage radish are pretty cool. So much so that we bought this machine last year to try and help develop. This is a power harrow air seeder combination that is pretty good at establishing cover crops. I think maybe to try and prolong the effects of the deep ripping, cover crops are probably pretty central to that. I think anybody who knows me knows I'm pretty fond of compost. This is a compost turner. We used to make 2,000 or 3,000 cubes a year of compost, which is a pretty handy sort of resource to have access to, and so we use that fairly liberally on a lot of those vineyards. Fertility biology, it's a conversation that we're all having, I suppose. But I think soil biology is probably the next green revolution, trying to release nutrients in our soils. Some closing remarks. Apparently cultivation has a few downsides and some detractors. But I think it has a place, and we've just got to try and, I think, it has a place, and it's worth trying to crack that nut. I've found it pretty useful in the operations that I've been involved with. I think, going forward, if compaction is real, and we probably show it is, we're going to have to work on adjustments to the practices that cause that compaction going forward. And I think, there's obviously sites that are not suitable for ripping, and that's where I'm wondering a bit about, biological tillage with cover cropping and things like that. And then some, further work on practices that can prolong the effects of subsoil ripping, I think there's a lot of scope for improvement there as well. Big thanks to Tony. We've been friends and colleagues for a long time, and putting this presentation together has been a lot of fun. And your help with the penetrometer has been great. Alf Cass really has done so much work in this area, and I encourage you to look up some of his material. Randall, the principal of Ag Soil Works, has been really helpful to me and getting to know his gear. And thanks to Richard.
Thanks very much, Lee. We might just hold questions for Lee for now, again, for the interest of time. Our next speaker is Tony, who will be returning to talk about some a soil compaction demonstration, soil compaction study that was recently completed in Margaret River. So, Tony, do you want to just set the scene while I get your presentation up and running?
So, as Richard will, I'm sure, acknowledge that this work has really been, this project's been funded by One Australia as part of the regional program, and part of that was just really to bring people's attention to soil compaction, and that's the result of what we're talking about today. But as part of that exercise, we thought we should take some measures in some typical vineyards here. So there were 3 vineyards that were chosen, which Lee has been part of in terms of the ripping side of things. So the three sites that we used, typical sort of soils, and there are 3 different years that those sites have been ripped. And so the idea of this sort of demo work was just really to see whether there was soil compaction as being picked up by the soil penetrometer, and also to compare soil penetrometer resistance readings under the vine, in the wheel tracks and the mid-row. So we've done exactly that process at 3 sites. At each of the 3 sites, as I said, there were rows which were also analysed, which had been ripped at different years. And that's basically the results I'm going to show. So
okay, apologies, Tony, and those online. We are back.
To assess vineyard soils in relation to vine and root performance. And this is Philip Myberg, who I met, and this is in one of the Coonawarra vineyards which I was working at the time. And as I say, they published this report in 1998, and I'm happy to even pass this around as we're talking. But in that, you will see that there's a whole range of data, but lots of pictures of soil pits, with roots coloured white. This restriction was caused by these hard, dense layers, with the degree of soil hardness or strength being measured with a penetrometer. Point 3 was that root growth was restricted if the soil had a soil strength penetrometer resistance greater than 2 megapascals, measured at or close to field capacity. And with this relationship being based on 22 sites representing a range of soil textures, grapevine varieties and irrigation systems. So that initial work has been done. Most of those sites they visited, they took a load of penetrometer resistance readings and dug soil pits to have a look at where the roots were, and that's what they concluded. So we don't need to repeat any of that. We can take that as
It's not the buttons aren't working, so you're just going to have to.
okay. This one.
Yeah.
So this is a typical example of what they are finding. So we can see that we go down to, so this was set to 900, the penetrometer. Critical resistance along the x-axis, 2 megapascals. That's the critical threshold range. So you can see, if we look at the vine row, that most of the readings were all less than 2 megapascals. If we look at the mid row, then we can see that there's some increase in soil strength, certainly around the 200 mil mark. So some sort of tillage pan that we talked about before. And then in the wheel tracks, again, much higher values than below the vine, and perhaps peaking around 350, 400 sort of mark. And then dropping down to 2 megapascal or a bit less as you went further down. So very clearly, underneath the vine, there was no compaction. Well, there was a degree of compaction, but less than 2 megapascals. So hopefully there should be no restriction to root growth and development. But in the mid row and the wheel tract, there was high values and likely that there would be less roots. And in their cases, after all those sites, they showed that there was indeed less roots. So the case studies that we had a look at here in this region. So 3 vineyards, deep ripped in different years, so 2022, 21 and 16. So the readings were all taken towards the end of June. We had 3 non-adjacent unripped rows, which we call the control. We had 3 non-adjacent ripped rows, which we're going to call the ameliorated rows. We took measurements along the vine row within the wheel track in the centre of the mid row. And recordings were made on the soil penetrometer 25 mil intervals, and we went down to 400. And the number of readings that were taken allowed us to basically get 6 replicate sets of readings. So the graphs that I'm presenting will be the mean of those 6 sets of readings. We also took soil moisture and bulk density measures. Soil moisture because it's important, as I indicated before, to ensure that we are around about the field capacity or close to. And salt bulk density is also a good measure to see of soil compaction, but also allows us to calculate volumetric water content. So when we take a soil moisture content from the soil, we take a sample, we dry it wet, and we weigh it wet, dry it, that's what's called the gravimetric water content. If we want to convert that to a volumetric water content, then we have to know the bulk density of the soil. So to be able to do, so we did that, and we felt, well, the measures would suggest that we were about 77% of field capacity when the penetrometer readings were taken. So not at field capacity, but pretty close to. So the 3 study sites, I don't need to dwell on this much, but Vineyard 1, planted in 1983 in Chardonnay. There's some information on the row spacing, gravel loam soil. This was ripped with a yeoman's 3-time plough, which picture that Lee put up earlier. The 2 times space to rip the wheel tracks and 1 down in the middle, which were ripped down to about 350. Vineyard 2, 3 metre row spacings, clay loam soil similar. In this case, it was ripped in 2021 with the Ag Soil Works vibro soiler, which again Lee showed pictures of. Just the 2 times in this case, down ripping to about 500, and very similar, same setup in Vineyard 3. And then that was also replanted. But again, mid rows, power hanger seed see it.
Which is the important point to pick up here is the timing of ripping. So there was one done basically last year, and then one was the year before, and the other one was 2016. So there's some quite wide range of time.
Yeah, and that's partly the reason with those particular sites that were chosen. So part of the legend at the bottom is not clear, so I'll talk through that. So anyway, vineyard 1, 2 and 3, all these are the control rows, so these haven't been ripped. So the blue line is the undervine, penetration resistance undervine. The green line represents the centre of the mid-row, and the orange line represents values within the wheel tracks. And again, I've copied the same sort of diagram that Philip Myberg and Alf Cass, etc. used. So we've got that 2 megapascal vertical line showing where there's likely to be some impact on root development. And the other thing I need to point out is that, as I mentioned before, there are where we have rocks or stones and gravel, there are some issues associated with using a soil penetrometer. And so even though it was set at 400, we didn't always get down to the 400. We encountered too much gravel or stones to be able to get the full depth of measurement. So in some cases, it's an incomplete data set, but the pattern is still clear about what's happening, I think. So you see quite clearly in all those 3 sites that values in underneath the vine row were all less than 2 megapascals. So some of those vineyards, as you recall, have been planted a long time ago, but still those values are still underneath or below 2 megapascals. So presumably, the soil is in good structural condition, and yes, they would have been ripped initially, but that's a long time ago. Presumably that the continuous vine root and soil biological activity that's been going on in all those years is, is helping to keep that soil in good health and not getting impacted. Plus, we haven't got animals tramping underneath the vine. We haven't got machinery really going underneath the vine. So there's no real reason why it should be compacted. So the highest soil strength were in the wheel tracks. So the orange line. Again, perhaps not surprising, but we've been going up and down some of those rows for many years. And it seemed to be about 50 centimetres seems to be the point in depth where some of that starts becoming greater than the 2 megapascal critical threshold. And the mid-row, the green, generally greater than below the vine row, but less soil strength values compared with the wheel tracks. So even the mid-row is getting, even though they're not necessarily getting a lot of machinery compaction. Having said that, an over the row harvester, of course, will have its wheel right down in the middle of the vine in the mid row. So there is some traffic going up and down the mid row as well. So that's I think a fair, clear indication that the value, what the Philip Myberg and Alf Cass found all those years ago are not dissimilar readings to what we're getting in our vineyards. Okay, so in Vineyard 1, this was ripped in 2002, so only a month before we went out into the vineyard to take penetration resistance measures. It's ripped using the Yeoman's 3-time plough, which got down to about 350 millimetres depth. So on the left hand side is that control row again, the same graph, but on the right we see the ameliorated rows. So not a lot, so under the vine row, similar sort of sequence of values, generally all below the 2 megapascal resistance. We can see that the mid row has been changed quite significantly in terms of degree of soil strength, as have the wheel tracks. So, to conclude from that is that obviously using that particular machine, that equipment, certainly reduced the soil strength that we were noting before doing. So really, these 2 lines here are really quite different. So it's worked in terms of removing soil compaction and reduce the soil strength. If we look at Vineyard 2, so RIT a year earlier, with the Ag Soils work equipment, 2 times in the wheel tracks ripping to about 500, and then mid-row power harrow seeded and roll. Again, compare the 2, the control, same graph, the ameliorated rows after the ripping. So certainly some differences. They're still quite high in the wheel tracks, but compared with here, potentially we're still seeing some reduced compaction. So this would be suggestive that it's had a year of traffic and it's recompacted certainly towards the surface, but it appears that perhaps even though there's still quite high values down here, there's certainly less than what it would have been a year before. So yes, there's been some. This would be suggested that there's been some recompaction, which is inevitable. There'll be some consolidation of soil, and it's been trafficked. So it's come back up again a year later. There's also the mid-row. There's some changes there as well, which is a little bit not understandable in the sense that we didn't have a time in the middle, but with the wind arrangement of time, maybe there's some shattering that has extended out into the mid-row from the wheel track. So possibly that is why there's some reduced soil strength following the ripping. And the third one, ripped in 2016, so a long time ago. 6 years of being trafficked again. And so compared, not a lot of difference between this set of results and this set of results. So it would suggest that 6 years down the track, and also replanted the amount of what's been happening on that site, would be suggested that it's been recompacted and we're back to pretty much square one. So just to conclude from that little bit of that work, using the penetrometer is an easy way of measuring it. There are some issues surrounding the gravel and rock in our soils, but it certainly gives us a good indication of differences, and the very fact that we can measure the differences quite clearly in the mid-row wheel tracks and under the vine would suggest that it's a good tool. We know that if values exceed exceed 2 megapascals at or close to field capacity, then root density in a lateral direction is likely to be limited. We didn't measure that. That wasn't the scope of the project, but all the work that previous people have done would be suggested that there is an impact on root growth. And as Megan said earlier, that's likely to be have some restricted access to soil water nutrient reserves. So even the data is incomplete in cases. The results show similar patterns to those reported in the literature, very much so. We've talked about how various options that we might be thinking about or can think about in terms of reducing or minimising soil compaction. One of which Lee's talked about in terms of deep ripping, but it requires, as you would have gathered from Lee's presentation, it requires specialised equipment. It requires a knowledge about how to do it. It requires knowledge about when to do it. And you know, there are people such as Lee around and others who have worked with this and have experience in it. There's also plenty of information in the literature, some of which I've brought along and you can have a look at in the tea break or at lunch. And of course, the data would also show that we do all this remedial tillage, but if we're not careful, we can go back to where we were before, and we may need to repeat it again. And again, Lee touched on that from his Franklin River experiences. And really, the point is, once we've perhaps done a little bit of initial survey with a penetrometer and see whether we've got compaction, then we need to dig some soil pits and see whether that actually is limiting lateral growth. I'll leave it there, Richard.
That's great. Thanks very much, Tony. And apologies, we are running behind schedule, but we'll continue on and welcome our next speaker, who I'm very thankful doesn't have a PowerPoint presentation. Is that right, John?
Trying to help you out.
Yes, thank you so much.
And it's all.
So our next speaker, John Fogarty from the Fogarty Wine Group. John is has been working in the wine industry for 25 years. Has a Bachelor of Viticulture from Charles Sturt University, and is a current board member with the Margaret River Wine Association and chairs their sustainability subcommittee. As director and head viticulturist of the Fogarty Wine Group, John oversees vineyards in WA, Victoria, New South Wales and Tasmania, equating to over 900 hectares under management. And yeah, John, please come up, and we look forward to hearing your thoughts on soil compaction.
Thank you. Like Richard said, I don't have a shiny presentation. I've got a few pictures to pass around the room instead. Lee called me up a few.
Do you want me to speak about some of those?
Sorry?
To...
Yeah, can do. Go with those first. Lee called me a few weeks ago about being involved with this presentation, with the sort of bits of work we've rolled through trying to understand what's happening in our own vineyards. I think the thing that I'd like to point out firstly is you've got the understanding of soil is probably the most critical component. As mentioned earlier, a lot of us spend a lot of time looking above ground, but we don't really spend a lot of time looking below ground, or as much as we should. So getting out, like, it's quite simple. You can use a tool like that, which I've used as well. You can get basic penetrometers that are a few $100, a piece of metal rod, and or just digging a hole. But yeah, it's pretty surprising. What I've found to date has blown me away a little bit, and changed my thinking of what we're doing. Not to the point of Lee's cultivation through the vineyards as much, but definitely trying to rip and to open up this compaction issue that we've got. So there's 3 graphs that I'll get passed around. We've got, there's a difference between rows that have had sprayer passes through and non-spray passes. All across, they're all in the same block, which is through in a vineyard in Jindong. We've got a number of vineyards that we've run. The Yeoman plough that was shown before, which is one we purchased a year ago. After lots of conversation in our group around what are we going to do? We know there's compaction there, but then where do we start? And kind of trying to understand a little bit more. One of our sites, we targeted these two sites straight away because we knew they had sandy loams and sandy clay soils that compact pretty heavily. They're both sites that are waterlogged quite often in winter, so we knew there was an issue with compaction based on that. One of the sites, which is Annybrook sort of way, had issues previously with compaction, and we've actually ripped it in 2010 with rips similar to these. From that was sort of looking at it, we knew we had compaction from like excess cultivation back in the day, plus also another point with that was probably higher magnesium and calcium ratios too. So we ended up with quite sort of thick soils that tended to glue up quite often. With tractor passes, they just became solid. So back then we'd manually dug holes to have a look, and we got to a certain point we couldn't get through it. It was that hard. So it was only about 300 deep. That was ripped back in 2010, and about a year and a half, 2 years later, we saw significant differences in the vineyard. Yields were probably about 40% higher than they'd been previously for around 3 or 4 years, then they dropped off again. We should have probably done something again sooner, but we were too busy looking at everything else and taking on more vineyard area that sort of was in the background somewhere. So we decided to then do this ripping last year on that site. We went through first, I borrowed that unit from Lee, went through taking penetrometer readings through our sites, and as I said, the first sort of couple of readings that I took just sort of went, oh shit, got a problem. I was quite surprised the undervine area was as low as it was. Like there was very little compaction under vine. I thought that would have compacted from irrigation or just through time, and you know, some cultivation practices too, but it hadn't at the time. Then our wheel tracks, you'll see in those graphs being passed around, the wheel tracks versus the mid-row, there is considerable difference. And there's actually quite a difference between the rows that we know we've generally had a spray card on compared to rows that haven't, which was, again, it was quite interesting to see what that component added to it, where the other rows still had barrel pruners, tractors with mowers, the vine herbiciding, all added in. So yeah, it was quite an eye-opener, and got me thinking a lot about what else we need to do. I think I rang Lee at the point and said, shit, we've now got a lot of area that we need to put this machine through. It's not just a couple of vineyards, we've got to do everything. But then from that point, trying to work out where you start and how you go about it. There's a lot of things that can go wrong. Most important thing is to make sure you do dive before you digs and check where all your irrigation is through the vineyards. We found an irrigation cable that we didn't know existed in one vineyard, which was not on any of the drawings for our irrigation install, which was quite a pain to fix. A lot of material that can be pulled up as well, like through the two vineyards that we did this ripping work in. It took quite a while to get the machine set up right. I think that's an important part of taking time, getting it right. The first sort of couple of rows that we did on one site, we were ending up with quite big open rip areas that were just going to be a big problem for traffic. We ended up changing the pitch of the machine, so how far it was pointing forwards, even without the wings. We found that made a big difference. But then also occasionally pulling up pieces of timber or rocks and things like that. So you've got to be prepared that if you're going to go down the path, there will be other works that have to go in behind it. So generally, like through two, so we went through every second row through 65 hectares of vineyard just on these, between these two sites. We had to probably pick up 3 or 4 pieces of timber out of all of that, so it wasn't really too bad, and we didn't have any rock. Some of our other vineyards, I know if we put it through, it's going to be a lot of work, so they're going to be later down the track. Yeah, it's a fairly daunting task, I think, to start, and you've got to work out where is the best place to trial and where to get going. Timing, as Lee mentioned, we found we're actually running it through when we're actually harvesting reds. We had a few gaps where we started setting the machine up and got going at that point. So that usual break of rains, I think around Easter, when you get some decent rain to be able to get soil moisture up, that's when we found we started, and then we got to a point in sort of May where it was just getting a lot harder and we were going to start making a mess. So you've got to be quite conscious around that, and just again knowing your soil types, because every soil type is going to have a different issue with it. So not with these vineyards, but with sites in Tasmania, we found the other thing you got to watch is if you've got any other soil related issues, like sodic soils, where you can then create bigger problem. There's not too much of an issue in the Mud River, but if you go ripping sodic soils, and especially ripping them to depth, you can end up with a lot of tunnel erosion, which can be a really big problem. So again, it's that key point of just know your soils first before you get going, to understand what is the best option. We ran with the yeomans as shown with 3 tines. I'm probably going to remove the mid-row tine this year because we found that created more problem than the other 2 tines, purely because it was opening up a lot wider. It didn't have anything behind it to cover or press back in, where our 2 wheel track tines had a tyre behind them, which was our depth setting, and they're not too bad to walk or traffic on. But the mid-row one, I nearly broke an ankle on yesterday. They can be hard work. So it's how you kind of set a machine up best to be able to minimise the amount of mounting you have in rows and trafficability. So from that, we didn't have, as Lee mentioned, with vehicle traffic into the vineyard after you've done it, we were worried about what was going to happen once we'd been through that process and whether we were going to get climbers in and out, and barrel printers in wet times, but we didn't see any issues at all with that across those sites with access into the site. We did only rip to 350, 400 generally, and we're sort of, that was explained by the suppliers of the machine when we bought it. They said, don't just go straight in and rip to, a metre deep. You're going to cause a lot of problems. Start gently, work up. So, rip to 300-400 this year, then another year, rip a bit deeper again, and just keep sort of ongoing that process.
And that's a really interesting observation in the data that Tony's done, and also ours. Most of the issues are 300 or 400. They seem to come back down.
Well, even
I didn't know that.
Yeah, when you look at those graphs, it's a lot shallower than that too.
Yeah.
So they show that compaction level can only be 50 mil. You haven't got a lot, and you've got a compaction point from there down that is stronger than what a root can penetrate. So for us, that focus, feed a root kind of depth, we know it's compacted just below the surface. So trying to rip that up initially to get feed root growth into the row was sort of a pretty critical part of it. One of the things I have seen as an observation, it's hard to see in these pictures a little bit, but it was significantly different. There was mid-row growth that we had across the site, from rip to non-rip rows. I'll pass those around as well, but the rip row had really strong even growth all the way down the row, and it was about 30 to 40 centimetres higher in height, and a lot larger density than the non-rip rows. Yeah, it's like for me, I drove into the vineyard one day and was driving through the headland of the rows and could just see the rows doing this in mid-row height. And didn't think about it first, and as I drove back out, went, wow, that's what's going on there. Got out, had a look, and it was purely that ripped versus unripped row variance. You can see there's a line on the unripped row where it declines. So it looks, there's quite a bit of growth at the start, but through the rest of the row where it's got that really hard pan, the growth is really low through that. The same thing that we notice across those two sites is they're generally always waterlogged in winter. It doesn't need a lot of rainfall for those two vineyards to have water pooling on the surface. Post ripping this year, we didn't see any water pooling at all on the vineyard, which I know it wasn't the wettest of winters, but it was definitely wet enough where we'd usually see that. So, yeah, there was some pretty obvious, obvious changes that had happened within the sites post ripping. So, things that we've, well, what I've written down in notes here are things we've learnt: timing, early after first rains. The floor can be rough, as I said. You can roll ankles, and staff working there in vehicles can be pretty rough. So how you set your machine up, what you use to fix that without compacting behind it. In this case, we didn't do what they did in power harrow and seed behind it. That was actually seeded the year prior. I didn't really want to go back in and then power harrow or rotary hoe a disc straight behind doing what we've done, try and fix the problem. You can end up with a lot of trash built up on the rippers if you don't have the right floor conditions. So again, that timing where you don't have green growth is best if you can, but you want enough moisture. As soon as you have a lot of green growth, without coulters in particular, the disc to cut through in front of it, you can end up with a lot of material balled up and you just end up pulling open rip lines and it becomes a pretty big mess. So I think that timing component really helps on that. Yeah, don't rip too deep to start. Every second row is a pretty smart thing to do. That was something Lee did suggest to me. If we ripped every row and it was a wet year and we had issues with trafficability, we would have been in a world of trouble. At least we could still pass on the opposite rows with spray rigs and things like that. So, and barrel pruners, it's only climbers that you're restricted to that. You've got to go down every row. And again, I think if you've had spray rigs running on the same rows every year, that's the obvious row to rip initially, and then plan for the other row the following year and try and work out how you rotate that vehicle movement. Whether you try and keep to the same rows every year or alternate rows, what is the best answer? I'm not sure, but I think we'll all have to wait and see on that. Then, yeah, I sort of came out with a pile of questions myself. How long will it take for us to do a pass again? I think if we leave systems the way they are, we probably need to do it every 3 years. If we can change what we're doing to, again, like have spray rigs running on the same rows and have at least rows that we know are going to be much better. Having much better ground cover makes a huge difference. Additions down rip lines as well. We're looking at that now with the unit that we bought. We've got what they call tickle pot feeders that vibrate as it's going through. Designed to drop seed, so you can actually drop grass seed into your rip line, which is going to help keep your rip line more porous by having good root penetration with, rye or similar grasses. But can we also then look at adding compost teas or something else like that biological into that rip line to help really get the soil active? While you're opening up your soil, you've got good aeration there, good water ingress. Can we, build biological health in that 30, 40 centimetre depth, which is really going to help again. So I think that's a really big one, and I want to look at that next, how we can drop something in behind down that rip line. What can we do to stop the issues? Like, we've got to look at better machinery. We're looking at machinery nowadays that is around fuel efficiencies and energy savings, but also compaction. We've all generally gone down the path of having larger machines that are comfortable to sit in and then have to narrow up tyres on them, so then they're going to create more compaction. So instead, we're better off looking at smaller machines, wider tyres, less compaction, tracks potentially. Spray units with tracks as well, there's options for that now. We're carting around 2,000 to 4,000 litres of water in a spray cart. There's a lot of weight in that. And in, you know, early spring, we all know we have to get on the ground and it's wet. How do we try and reduce that issue? So is that a better option, or is it tyre sizes, or is it less water in tanks, or, you know, what that might be? We went down the path of going for, nowadays I prefer smaller spray tanks instead of 3,000 or 4,000 litre tanks. We'd rather run like an FMR, which is 2,000 litres. We still get a decent amount of ground coverage with less water. So, you know, those things make a big difference. An extra 1-2 tonne being carted around in spring makes a big difference on the compaction. And then, yeah, there's timing of things that we know we have to do, like barrel pruning, cleaner work in winter, spraying in early spring. We can't get around them, so that's just how we better them. Barrel pruners should we be doing with posi tracks instead of tractors that are causing issues. So again, it's just trying to work out what are the smarter options to help with that. So
it feels like that spring period when we've got sort of 3 or 4 sprays to put on when things are pretty wet. That might be a really good opportunity to half fill our spray units. And I mean, I don't want to deal with the efficiency cost of that either, but I feel like that's probably what we do.
Correct, and that's the thing. Like we all know, at the end of the day, for us as our jobs, we're going to try and do things as efficiently as possible. But we also need to make sure that we're not just constantly creating more problems that we then have to spend a lot more money on later. So yeah, it might be more efficient to have less water in tanks to start early in the season than having a big problem you to resolve in 5 years' time. Yeah. And then my final note was no cultivation, Lee. Yeah, sorry, had to do it. We've had an ongoing feud about this for a long time. Soil structure's the important part with this. Like cultivation is destroying structure, so we're going to make more compaction by having finer particles. So yeah, don't do it. I also brought along, that's the invoice for the yeoman. We paid 14 grand for that unit. I did buy a lot of options with it that we don't necessarily need. It was just more around getting the equipment here and not having to try and get parts from Queensland where they're based. I'm by no means pushing that plough. I know there's what Lee's got, DPIRD Soil. There's also a few other brands.
Agro plough.
Yeah, agro plough. Yep. So there are plenty of options. I went with Yeoman because it's a brand that's been around for a long time and they've done a lot of work in Broadacre with this. We've seen it. Pete, who's got a smile on his face down the back. We had a Yeoman plough run through a paddock at the Sandalford vineyard, which blew me away. That sort of pushed us to buying this thing. It was a block that had been fallowed for a long time. It was walking around on the block was like concrete. A neighbour went through with a Yeoman's plough that had tines every, were they about 30, 40 centimetres wide?
Probably would be that.
Yep. Post the plough going through that paddock, it felt like you were walking on pillows. The whole floor was just floating. It had that much air in the ground that it was just moving around like that. It felt pretty bizarre to walk on. We had a 50 mil rain event 2 days after it was ripped with the Yeomans. I was absolutely shitting myself. The whole paddock was going to be down on Harmons Mill Road. Went out there and there's no sign of water runoff anywhere. It all just infiltrated straight to the ground, and it was perfect. So yeah, I think it proves in that sort of thing, but it also, you can see what's happening in Broadacre as well. It's a pretty common practice in Broadacre, and there's a lot of data showing what sort of difference it makes. So yeah, I'm fairly changed on that one now, but it's how you best go around individual sites. Take time and learn your soils first, and then sort of work on a solution.
So just from a branding point of view, ripping is not cultivation, so you know it's fine with ripping.
Correct, that's why.
So it's fine.
Thank you.
Thanks, John. Thanks for those really cool insights that you've Yeah, just over there. Fine. Thank you.
Yes, well, I've got the floor for 1 second. 35 days is a good rotation, good number just to use for your rotation. But if you want to get my number of Richard later on, maybe a bit more about the programs we do, but for ryegrass, we work between somewhere between 21 and about 50 days, depending on the season. So, yeah, to leave sheep off. Yeah, 35 is a good average.
Yeah, thank you, Peter.
It's still a sandwich in land.
Yeah, go for it. We'll invite our presenters to come back to the front of the room if you just want to swing your chairs around, and we'll start the Q&A.
Hey, John, what's the machine done? How's he doing with gaps? So, go through written.
Have you got what
The gaps in the soil, like, is it noticeable or trenches?
the sort of 2 times that we had behind the tractor tires, which had the like the standard car wheel behind them as the depth stage.
Yeah.
They weren't too bad. They sort of, it pushed what was there, sort of an open little V, and it wasn't that noticeable. You can still feel it walking around.
Yeah, sure, but yeah.
Where the one in the was quite open. So hence why we're able to take that time off. You can just get the time up or try and adjust something behind it. It does have a crumple roller go behind it, but we didn't use that in some of the sites. It's quite right behind the machine. So we're going to play a little bit to see how we can fix that together.
Yeah, for sure.
Yeah, like I said, keep back into your function.
Yeah.
What size tractor?
That was generally running up the North Patch. So it's what most of us standard ones. We didn't really have any issues with it at that depth. This area, and then you hit something and it does pull it up a bit. And we were running speeds of around 3 kilometres down 4 kilometres an hour as well. With those times, they're quite narrow times, so they weren't too bad. Yeah, didn't really have too much issue with those. Pete, from your side, when you did
No,
those,
it was pretty good.
Yeah.
I mean, having used what the lease machine and the part of the reasoning behind looking at the yeomans initially was to try and have something that didn't make as much of a mess in terms of having to go in and work behind it. But there are a lot of advantages also of the old machine, but this was almost like something you could put over, break your hard pan or whatever in your tyre line, and be able to use it without making a mess probably every 2 to 3 years, whereas you have to do a lot of good prep, and Lee's use that time to, when you use a deeper ripper, to actually ameliorate the soil as well. So
yeah,
compost or fertiliser or whatever out there. So I think, you know, every one of those machines has their strengths and weaknesses.
I ended up putting a, I think it was a 600 or 700 mil coulter in front of my clients. Yeah, same thing in trenches, it's huge.
yeah, without a collar, it's
Yeah.
hard work.
And so you coulter it, you know, even if you go down 300 or 400 with the coulter, still so much roots underneath that just slide up in time.
Yeah. And that's where I think timing is important. We found the coulters on that are 800, so they're quite big.
Yeah.
Initially, we had a little bit of trouble getting them set right where they're actually cutting well to be able to get the time in. When we first got the machine, we just put it on the tractor and mucked around with it for a couple of days, and it was in a different site and quite sort of clay soils. It was quite heavy, a lot of grass in there, and that was a mess. It just kept clumping up, and there was grass on the tiles. So hence, I think that timing, and if you can get it before you have too much green ground cover, where you can cut through quite clean, quite neat, is probably the most important. Otherwise, you end up with, yeah, just displays like it's devolved.
The other thing I would say about the yeomans, they do have, and I wonder if it would make any difference, they do have like a what they call a shakerator on, which actually vibrates the
Person in tractor.
to a point. Sorry.
The person in tractor.
Oh. Stop it.
Yeah, that also, there's a lot of different tools and times you can get for them. Like when we order that, you can have a look online, and they've got a red book, which is their book with all the specifications and what they suggest to do. You can get 20 different tip points, you can get wing chips, you can get shaking option. I was looking at it and I just sort of went, I don't know where to start. Like, it's quite confusing with so many options, and I spent about 2 hours on the phone with the owner of the company who told me his life story and the whole theory behind bricking and what it does for your soils. And all I wanted to know was what I should buy. Gained a huge amount from it, and he literally then said, just start with the simplest. So get basic option, straight points. Don't try and do too much at the start, and just get the program going and get it to a point where you sort of open up soil, getting rid of your issue, and then if you then want to look at anything further, go from there. But yeah, it was quite a simple setup in the end.
Yeah, I think that's good advice. And if I've learned anything, I reckon probably didn't need to go as deep, and the compaction data of the penetrometer shows that. With, you know, the extra effort and problems that come out from trying to get to 600 or 700, probably not worth it. So yeah, that's something that I've learned.
Yeah.
Just a question on the decline in the vineyard. So was the decline in yields, or was that in vigor and yield?
Both, you know, the overall capacity of the vine is just struggling. So, you know, yield is the, I guess the, you know, the measurable, you know, aspect of the system, but you know, the vines are struggling. They're not resilient, or they weren't resilient. They were sort of pretty, you know, affected by environmental conditions, which I think, you know, one of the things prior to moving to that vineyard in Franklin, I've been running pretty old dryland vineyard in Margaret River, the Forest Hill property. And that never, like, it's really interesting if you've had much experience with dry farm vineyards, that they're a bit like older people. They just don't seem to worry about what's going on so much. They just get through environmental conditions with less sort of variation. So I had that thinking in my mind moving to Franklin and going, well, yeah, we need bigger, you know, root systems to try and, you know, buffer environmental stresses. Simple.
Like chips. Filtration, compaction.
Maybe John?
What was that on gypsum?
Gypsum applications of gypsum, five-place soils.
Yeah.
Just increasing the information. Slowly literature.
Yeah, well, you're going to get some effect from that, but if you've got a compacted soil, it's not going to fix it really. But also the thing with doing it is ripping too, if you need to, it's a good way to add gypsum to put it down the rip line.
Oh, while you've got the rip line then, Mike, you might as well stick with everything you need. You know,
Yeah.
you can do down it. So, you know, compost, gypsum, lime, if we're going to you know, use the opportunity really.
That's what we've found in Tasmania. We've done that in a lot of work now as well. We've actually set up for all of our establishment, we've done 200 hectares down there, and the whole vineyard being ribs. We've had different depths of ripping based on soil types and what we know with soil issues, but gypsum's been a big one with some of those sodic soils. We've been dropping gypsum down rib lines. So we've actually set up a unit with an air seeder on the front of the tractor that has a adjustable depth placement tube on the back of the ripper. So we can place the gypsum to the depth we want to within the rip line.
That's pure gypsum.
It's pretty agricultural, yeah. It's a pretty agricultural way of doing it, but it's worked really well to be able to use something like an air seeder to be able to do that, where you can just feed what you need to back into those rip lines. Because if you're going to do it now, like, you know, we know when we pre-plant, we put everything we can in, and then you get to this point 20 years later, where you want to try and add everything back in, gypsum, lime, and the likes, they're all quite hard to pull on the surface to actually get into depth. Yeah, it's a good opportunity to do it too.
I might just have one more question and then break for lunch and continue the discussion over lunch. Anyone got a last question online? No?
I'm just wondering in terms of moving forward within the sustainability sector and one of the conversations with carbon credits and carbon sequestration. And I understand you said that where deep ripping is different from cultivating, but kind of where does it fit in that conversation in terms of what companies need to pay attention to if they're seeking carbon credits?
Well, it's a big one. I said this to Lee the other day, actually, after going to Porto recently for a tech conference over there. The French have obviously cultivated heavily for a long time under vine, and they're now talking about carbon very heavily, but at the same time going, hang on a minute, everything we're doing, we're kind of taking carbon away every time we go through doing any passes like that. So they're cultivating, which is removing carbon, and then trying to work out ways to put it back. So they're talking about a lot of cover cropping now, which we've already been doing for a long time. So I think that's definitely a big pass, but yeah, I think it's how you look at any soil works like that where you're going to be stripping carbon. It's a big one. Yeah, I don't know. Personally, I don't like that option of cultivation for all those reasons, but there's reasons why you do need to cultivate if you're not using herbicides or you're not doing something else within the vineyard, or like they have a lot of issue with frost too, which bare earth is better for frost. So
But in terms of deep ripping, where it fits into that conversation.
Well, deep ripping shouldn't have any effect on carbon reduction. If anything, it's also a good time that you could add carbon potentially back in the organic matter. Yeah, so I think it's another potential to help. But I don't think there's any adverse effect on carbon with ripping.
Might be less with cultivation.
Yeah.
Okay, can we have that one over lunch? Right, so I'm just mindful that we are half an hour over. So let me just finish up by acknowledging our presenters. So I really appreciate Megan dialing in from Adelaide today. John sharing your Margaret River experiences with us. Lee supporting this activity as the chair of Wines of WA Tech Committee. Also co-authoring the article that you have with you today and access to your penetrometer. Really appreciate that. Thank you. Tony, your time and guidance for this work and this workshop was really appreciated. And also your authoring the article. I think, and we intend to have that published in one of the industry magazines in the coming months. My colleague, Yui Lau, she was actually the one taking those measurements with the penetrometer out the vineyards. And then our funding bodies, Wine Australia through the regional program, and Wines of WA who administer that on behalf of the WA wine industry. So thank you for all of those that contributed. And there are a survey in front of you, so that's 3 questions. So really appreciate you giving us some feedback, and if we can all just thank everyone that was presenting today. Thank you. And thank you to our online attendees.
Thanks, Richard.
All right, thanks.